Kia ora koutou. Thank you for joining us this session. My name is Rhys White, and I work at PHF Science, and I will be chairing this session this morning. So up first we have Eva, who's going to be talking about integrations for a more connected research platform with Open OnDemand. And Eva and I are both part of the same club, the Cool Shoe Club. So yeah, round of applause.
So hi everyone. Today I'm presenting on behalf of my colleague Yuriy, and today I'm going to talk about two practical integrations that turns Open OnDemand platform from a simple access portal to a more connected research platform. So a few words about us as a company. We are independent and partner-agnostic team. We are specialists in HPC and AI services. We operate globally with offices in Europe and New Zealand. We are not providing hardware. We provide 24-hour support capabilities for your HPC and AI workloads. So we accelerate scientific discovery, product development, and AI innovation. We deploy, design, and maintain HPC systems so our clients can focus on innovation and research, not the complexity. So as I said, we are not providing hardware. We provide HPC and AI services. So our services cover installation, support, R&D, and consultations and training. So we are part of a global HPC community. We contribute to such projects as Easy Build. We work with Open OnDemand, and we also support diversity and inclusion initiatives such as Women in High Performance Computing and other European projects. So now let's talk about Open OnDemand. So what is Open OnDemand? So Open OnDemand is a platform that brings HPC to the web browser. So this is a platform that provides simple, secure, web-based interface that gives users seamless access to HPC resources. So this is how it looks like. Very simple, but actually very powerful. Why? Because it gives us a complete research experience in the web browser, like user research experience. So Open OnDemand is plugin free, so users can get started without any local installs. So the file management is very easy and straightforward. Users can upload files, manage, transfer them. So the users can manage, monitor, submit jobs. They can open command line shell access. They can launch graphical desktop environments for visualization. And they can run interactive applications like Jupyter Notebook, RStudio. And Open OnDemand is very highly customizable. So for example, you can implement different integrations in Open OnDemand. So we customized Open OnDemand by implementing two different integrations. So first is we integrated Easy and Open OnDemand to create interactive app design. So if you attended my talk yesterday, you know that Easy is a project that provides a consistent, optimized software stack. So why not to implement Easy under Open OnDemand interface as an interactive application? So we did that. So with that, you can have identical environments across different systems and sites, which is ideal for training, testing, and collaboration. The second integration is we integrated Grafana directly in Open OnDemand to create Grafana viewer application. So why it's important? So you know that monitoring is essential, but it's often fragmented. So we have separate URLs, separate logins, and dashboards are usually exposed outside of the user workflows. So these are barriers that we want to kind of eliminate, and that's what we are doing with integrating Grafana into Open OnDemand. Plus, users can get secure role-aware access to the monitoring, so they can access their dashboards and metrics that are relevant to them. So let's talk about first integration, interactive app design. So just a quick, so imagine the story. So you have two HPC centers. and both of them wants to install GROMACS. So what it means for admins. So they need to collect user and build requirements. They need to build full software stack with easy build spec. They need to adapt recipes for local environments, etc. Tune, validate, maintain. So eventually you have like 2 different builds, and admin work doubled. And you can't really share these binaries. So that's why EASY exists, right? So EASY is a European environment for scientific software installation. Just recap the slide that I have from yesterday's presentation. It's a collaboration between different European centers, HPC centers, and industry partners. And the goal is to build shared stack of scientific software for HPC systems and beyond. So EASY provides public repository of optimized scientific software installations. With EASY, you avoid duplicate work by collaborating on a shared software stack. Users access software in a uniform way, regardless of the system they use. EASY designed to work on any Linux distribution and system architecture. So software stack is already tested and optimized for specific software. So this is the performance automation testing collaboration built from the start. Yeah, just a simple representation of EASY. You take EASY takes your GRAMACS application, automatically stream it to HPC system, on-premise cluster, cloud VM, or your personal laptop. So now let's talk about this interactive app design use case. So by implementing this integration, we don't need to rely on, we don't need containers, and we don't need repeated software installations anymore, right? So deployment gets easier. In terms of software sharing, with this integration, we improve collaboration among HPC centers, so and improve scientific software development and reduce also duplicated effort. And in terms of training, this integration offers continuous learning without being limited by local setups, training environment setups. So let's talk about it a little bit more detail. So first is, the first feature is deployment simplicity. So I will be using a Jupyter Notebook as an example here. So with EASY, you don't need to install Jupyter Notebook manually on each HPC system. Imagine like traditional way of doing things, right? You need to choose the toolchain, you need to compile the list of dependencies, you need to optimize everything for the HPC system for a specific CPU target, right? With EASY, you don't need to do that because Jupyter Notebook is already optimized. It's as a part of a shared software stack. So you just need to basically load EASY environment, source EASY environment, and load the Jupyter Notebook. That's actually what's happening in the interactive app application under the hood. So you can see this is the script that configure Jupyter in OnDemand. So we have we source EASY environment, we load Jupyter Notebook, and then we launch the Jupyter Notebook server. Easy. Yeah. So from the OnDemand interface, you can you choose your interactive application and launch Jupyter Notebook job, and click you can launch. And when it's started, you can connect to Jupyter. This will open this Jupyter console, and you can see it's running. So you can see that EASY automatically detects your, I don't know if you can see it. So it automatically detects your host architecture and choose the matching, the optimized Jupyter version, Jupyter Notebook version for this specific architecture. Yeah, so let's, yeah. Another way, software sharing is also enabled with OnDemand. So for that, we develop desktop application. We call it EASY General App. So, so this app launched desktop-based session, which is integrated with the EASY environment. So from the user interface, how it looks like, you choose your module, any module you want to run, and you could click launch. And now let's have a look at the demo so you can have a clear idea how it works. Can you please run video 1? Thanks. Yeah, OK. So we run our easy general application. So we choose models we want to run, upload and run. So for example, it's GROMACS version, yeah. And let's say Python. Yep, launch. It will take a while. All right, so we probably need to refresh the page. So yeah, OK, it's running. So you can launch easy app. So we open in, all right, OK. 5 minutes, OK. It's good. We're connecting to our session. So here we want to open terminal to run GROMACS. So we type terminal. Come on. Sorry. Sorry about that. And then we run, so all these both models that we choose in Open OnDemand interface, they're available. So we just run version for GROMACS. And that's it. You can see it. Thank you. Right. Next. OK. So if your HPC center has this integration and they want to share it with the other center who also have the same setup, and let's say like center 1 wants to add more a new software in easy, this software will be automatically available for the collaborator, you know what I mean? Because they already have the setup and they're already available in easy. So sharing is very easy here. As I said in the beginning, at Do It Now, we provide trainings to our clients. So usually how it works, we provide our training session on the client production system. So it takes time for us to, wait when the training environment is ready. So if something goes wrong, we have to delay our training, which is not good. So we propose this solution. So we can set up a training environment. We can prepare a basic cluster environment with cloud providers. We can install Open OnDemand automatically using in-house delivered Ansible playbooks. And then we can enable access to software through easy. In this way, we don't need to rely on the client production system anymore. So we just, yeah, so the training can be faster, delivered faster. Yeah, so in the end, what users get, they get reduced software deployment effort across centers, applications available immediately after setup. So you don't need to install, so no model setup inside sessions, access to consistent software stack, we Open OnDemand, and improved reproducibility for training, testing, and collaboration. And now I promise quickly, talk about Grafana Viewer. This is our second integration. So in this case, Open OnDemand acts as a centralized portal. Grafana operates the same way as designed. The only difference, it's not exposed directly to end users. Also, Grafana role-based access control enabled. So users get access to dashboards and metrics that they authorize. To authorize, they have access, right? User identity is mapped via LDAP. So in this diagram illustrates how monitoring is integrated into Open OnDemand. So on the left, we have SLARM. This is the source of workload, jobs, and node data. Then we have plugins, exporters. They are collecting the logs and metrics. So Prometheus metrics are scraped by Prometheus. Logs are indexed in Elasticsearch. On top of Elasticsearch in Prometheus, we have Grafana. Grafana provides dashboards for users, and then we have Open OnDemand that acts as a centralized portal. So you can see that here Open OnDemand looks like a secure front door for monitoring. So users can access monitoring in a familiar way. So where they run application, where they see their data, so they can see how they use this data. Quick demo. Can you please run video 2? So how much time I have?
We're just in question time.
Okay. Yeah, so this is how it looks like. So you can see different images here. So for the Open OnDemand apps. You can also, this is more like static images. You can go to dashboard if you want to have more like interactivity. It will take a while, sorry. If we can maybe speed up the video, because it will probably take 1 minute to upload Grafana. Yeah, so this is how it looks like when we use dashboards. Yeah, you can see we use LDAP to map our user identities. I think that's it. And I have one more demo. I think it's the next one. Yeah, the last one, yeah. Okay, so what's going on here? So we have a Grafana admin group here. If we go to administrator, teams, we can see the members of this group. It's HPC test user right now. So we go back to Open OnDemand. We see we logged as HPC Now test user. We can see the dashboards. We can run Grafana viewer application. And you can see the available dashboards for this particular user, images and dashboards for this particular user. Yeah, the same. Now if you go back and choose a different group, let's say, which one? Yeah, we go to team Open OnDemand. Yep. And we have Lear, another user, Lear. Now you see we logged as Lear. If we run Grafana viewer application, you see, I think it was 2 applications, remember? Yeah, 2 dashboards, so it's for this particular user, right? We have SLARM jobs and Open OnDemand applications. So if we go back and change the permission for Open OnDemand application. Okay, just quickly, almost done. Yeah, we remove Leah from the group. So now we only have 1 dashboard for SLARM jobs, right? And so I will stop this demo because the next thing is just to add Leah back, and you will see that both dashboards are again available. And the last, I think, I have the last slide. Oh, wait. This is the one that I have. So the last slide, what we get with this integration. So we have a monitoring tool implemented as a passenger application, and we have security access control while exposing relevant metrics. So we use airbag, we use LDAP-based role and team mappings. User can see dashboards relevant to them, and we have secure access to system and job monitoring. Yeah, and also just to want to mention quickly that every month we run OD tips and tricks sessions that include different short demos, real-world tips, and open QI sessions in collaboration with Ohio Supercomputing Center and us. So the next one will be on Monday, so you can scan this QR code and attend it. That's me. That's it. Sorry.
Thanks, Eva. In the interest of time, we're just going to move straight on to our next presentation. But if you have got any questions for Eva, make sure you catch up with her in the mini break or for lunch. So up next, we have Nat and Yuriy, who are going to be talking about smarter storage, data, and file system management on REANNZ Advanced Computer Platform.
Thank you, Rhys. We'll wait for the slide. Yeah, no worries. Thank you so much. All right, smarter storage at REANNZ. I don't know if you have followed a little our story. It's now around a year. We decided to do a platform refresh of all our system. And we wanted to come back on that, explain what we did and our choice, and also make sure that you understand what their capabilities are, and hopefully it's useful to you. When we came to this migration, we had lots of wants that we wanted, and our user came and had a huge list of needs, GPUs, yes, working fast, but the most important was scalability, easy to scale, to add more resources to any storage. We had also a cloud that we were starting, the Researcher Developer Cloud, then you can subscribe to, and we wanted also good storage for it. We had a nearline system, which was a terrible failure, sorry to say, archive, and it was a pain point for us. Then we had quite a lot of problems, and we wanted to make sure this was going to be fixed. Then I think if you went to the first day, on Tuesday, Paige Martin did a very good talk, and she introduced this software-defined storage term, and I thought it was really good because it's what we have been using, and I think it's really good to hear it from other people that they are using it. Then we wanted not just usage, we wanted something to support users, support user in every part of the life cycle of research data. Then it can be at the start of a project. You need data, quick. You need access, When it's intermediate, you want also something that you are going to create lots and lots of files, and that all these temporary files are cleaned up automatically. Yes, we have an example. How many files did you get? Yeah, million, hundreds of millions of files that some of our users are creating temporary. We have to clean that up, okay? It's critical for them, for us. We want also to preserve, data for long term. And that was also quite an important challenge for us. Then this was our requirement, and this is why we came up with. Then we are first our HPC storage. Then we call it, we have free-file system, home, project, and scratch. Sometimes we call it no backup. Then just for people that will know that. You can read all the benefit of it. But what I will say about it, it's amazing, it's scalable. We don't need to wait, long maintenance period to add storage to it. It's simple. And I think Amber did a presentation on Tuesday too, and she mentioned it, we had not enough at the start, unfortunately. We added more, and now we are, covering. It's great, and it's fast, very fast. It's using Weka file system, and yeah, we have been going for quite a lot, and from GPFS, it's really, really good. We can see the benefit of it. But I will not go through the long list, but one of the things that my manager, that I forgot to mention, Blair Bethwaite, which is the mastermind behind all of this architecture, and I should note that, it's also multi-tenancy, and I think it's very important to us, We can cater for a lot of people. We have also overstorage, as I say, for our cloud, the researcher developer cloud that you can subscribe to. We use Ceph. We have a mixed range of SDD and HDD. The HDD are the old system. We kept up the storage. Why not, reuse, recycle as much as possible, and it's really worthwhile. And we have our freezer that I will talk a little later in more detail. Nearline was, as I say, was our previous. He was only media management. He was not very good. This one is software-based. He has policy. He has really lots of features that we are using. Data management. How does it come into place? Then one of our data management person, Claire Rye, that is also present at the conference, and you can talk to her at NECI, helped us quite a lot in data management over the few years. We try Starfish. This was one of the tools we tried when we wanted to do the migration from our GPFS to the Weka file system. We had so much files, never looked at. We didn't know what we had. This is just a bad thing because it's only our scratch or no backup, as I say. I could not find the picture of project. It would have been scary. It was red, very red. We had data for so far. And it was important for us, during the migration to do something about that. We wanted to make sure we only migrated the good, the data that was useful to people. Then Starfish helped us quite a lot at the start to make quite a lot of analyses and reports like that, which was really good for us. Unfortunately, we could not use it at the end. Bloody expensive, if I can say. Then it didn't work out for us, but he helped us at the start during this migration, at least to have a view of what we had and be able to manage it. But we came up with other strategies, because it's what we are. The first one is what my colleague Yuriy is going to talk to you in a few minutes about Guffy. We implemented it, and this is a great tool. I really recommend it, in particular for people that own, some storage, and is becoming quite big. Guffy is amazing. It is fast indexing, search capacity analysis of large file system. Wonderful. And as I say, Yuriy is going to talk about that. On that, we use we completely redesign our cleanup process based on Guffy, and it's so fast compared to what we had. 170 million files to delete. How long do you think it can take? We delete petabytes every 2 weeks. Guffy is helping us. It's the scale of it is so huge that sometimes you like, poof. Okay, not petabyte, maybe 100 of terabytes we are deleting. Then freezer, yes. And as I say, I will talk a little later about it. But freezer is really good for data management also, because we have a lot of projects that become inactive, or users that, have not logged or, are not really active anymore. But all the data is still there on their home or project. What do we do with it? Then we are putting in place a system where this data is going to be copied in freezer. Give them more time. We will contact them, try to find owner at the institution, for this data, and not just leave it on very expensive and fast HPC storage. We want to put it in a place where it doesn't cost, but we don't, delete it, and we can deal with it and talk to the people about it. Then, yeah, it's the workflow we are trying to implement in the next few months. that's it for the first part, and I will let Yuriy talk about Gafi.
Okay, so Nat was talking about the starfish and how we used it to inform decisions about the migration, about what data to move and how to move it. And we couldn't use it later because it was too expensive. So I think it would be nice to have something like this during the HPC operation, because you want to be able to understand how the file system evolves and the distribution of files. So for example, I had to look at the problem we had recently with the file transfer, that users couldn't move data between REANNZ and HPC and University of Auckland. And when I looked at it, not only was it not working, it was also crashing our transfer node. And when I looked at the directory they tried to move, ls would simply hang, and eventually it would crash because it ran out of memory. And how would ls run out of memory? Well, it tries to sort the output, and when you have 50 million files inside a single directory, it takes a little bit of memory. So it would be good to be able to understand the distribution of files and to detect the sort of hotspots and advise users on what to do. Globus, of course, has its own limits on the file transfer, so you can transfer, I think, up to 5 million files in a single go, and a lot less inside a single directory. And another thing is we have 700 million files. About half of them are less than 4 kilobytes in size. And if you wanted to, you could fit all of that in a single 1 terabyte SSD drive. I'm not sure what to do with this information yet, but it's interesting. So what is Gafi? Gafi is basically it's a tool to create an index of your file system. And the way it works is it will take the directory structure of your file system and it will replicate it. So for every directory inside the for every directory, you will have a directory inside your index. But instead of having files underneath, it has a bunch of databases that describe the tree under it and the contents of that directory. And then the set of the tools that they provide will make this look like a single giant SQL database. It's just faster because it will spawn multiple threads to try to crawl it and return the information. Yeah, so it was developed by the Los Alamos National Laboratories. It's open source. It was developed as a part of the MarsFS file system, which is POSIX file system. But the tool itself is a file system agnostic, although it does use features of the underlying file system. So if you have, say, GPFS, it can create index much faster because it uses the GPFS policy engine. Unfortunately, I don't think Veka has anything to speed up the metadata operations. So when you create an index using Gafi, it will have to traverse the entire file system. So the biggest challenge of actually implementing it was to make index creation fast. We started by running it on a single virtual machine by mounting POSIX, by mounting Veka as a UDP mode. And it took, I think it took about 30 hours to create the index of the file system, which is not very good when you want to do it continuously and you want to have the fresh index all the time. So what we did instead is we used something called DPDK mode for Veka. So it's just a way to offload the network processing to the user space from the kernel space. And it requires SRIV interfaces on the virtual machine. But it made things a lot faster. So instead of 30 hours, it takes about 3 or 4 hours to run, which is almost acceptable. I think it also allows you to speed things up using Slurm. We haven't tried that yet. And another thing that it needs to do is it always creates a new index from scratch. It doesn't create index incrementally. It's also something that we are trying to work with because they allow to create index incrementally, but they don't have a very good documentation how to do it yet. But yeah, after we switched to DPDK, it became quite acceptable. And we haven't used it in Anger yet, but it allows you to do the regular queries. So in addition to the query tool, it also has a bunch of scripts named Gaphy du, Gaphy find, and so on that lets you run the stuff. So lets you run the standard Linux commands on the top of the Gaphy index. And it speeds things up for users maybe 3 or 4 times, which is nice, but it still gives you a bit of time to have coffee, so it's not too bad. We don't want to speed things up too much. Yeah, and yeah, so NVV, we have the everything related to index creation in a repo, so including the creation of the virtual machine that mounts Veka, and we run it as a part of the pipeline, part of a shelled pipeline in GitLab. Okay, that was all about Gaphy.
Thank you. And I will go fast, I see the time. Sorry, I took too long at the start. Then yes, Gaphy, very interesting. I really recommend if you are interested, yeah, reach to us. We have now knowledge that we gained difficultly, but it's working well, and it's really worthwhile. Freezer, you may have already heard about us talking, but we have very good documentation, okay? If you go on our support docs, and by the way, Gaphy is also, you have some good documentation on the support website. We have even a webinar that we recorded, then yeah, don't hesitate. Then tape in 5 seconds, it's cheap, it's low, slow, very slow, but also it can last for long, you know, than your data. Really worthwhile. S3 interface, easy to access. Dedicated space. That one is interesting. We have created pools. For example, we have a pool called University of Auckland. In this pool, we have a set of tapes, and we only save data linked to the University of Auckland on that tapes. It means it's extremely portable. If one day, you know, the university wants tapes, it's, you know, we can completely separate them from the rest. Then we try. Yeah, and we are quite open to other pools if needed. We have currently 6 or 7, but yeah. I put here some use cases. I am not going to go through them, but you can read them. Why Freezer is extremely useful, and we recommend it. The only caveat that I want to talk is for the 4 last, where we recommend you to have 2 copies, always 2 copies for data that cannot be regenerated. You know that you are going to want to keep them. We want them, we have only 1 copy on Freezer. Then we are working to make 2 copies, but what we recommend is keep 1 on your institution, you know, storage, and use Freezer for the 2nd copy. Very good. You can read, it's secure, it's integrated, it's a very good tool. Few tips, compress your files, please. GitLab repo, we have a lot of them. They ask us to you know, archive. When you have millions of little files, it's not very efficient. But it's also the same with Globus, okay? Then if you do transfer, usually try to compress your files, in particular if you have lots of small files. What is great about Freezer, you can ask as many allocations as you want. Use it. They have names too. You can put names that are useful and meaningful. You can call them your project, but not only, it can be your project and snapshot with a date. Yes, it's wonderful. You can put whatever is needed. Use it. It's really worthwhile. We have lots of plans for the future with Freezer, more copies, as I said, dedicated Globus point, like that we can do transfer already. I heard from support that it is something that is required by user. Yeah, then lots of tighter integration. But it's not finished. We, at REANNZ, we take data management very importantly, and I'm working also, because if you go to our portal, mynesi.org.nz, we have project and allocation, but it doesn't work well for data sets, and when active data sets are shared between projects. We would like to also bring some more, you know, way of managing these data sets. And yeah, if you have some requirements, if you want to talk to us, yeah, I'm very happy to talk to anyone or at REANNZ. Thank you. Yes, we did it.
Thank you, really great. We do have time for 1 question just before we hit the mini break.
So can Freezer be used as an effective archive? Would it be suitable to do archiving stuff, and would it be cost effective?
Sorry, can you say again?
Can Freezer be used as an archive? Is it the purpose, or is it some purpose that we can use it for?
Then, yeah, if we go back at the use cases, do you want me to show?
Oh, well, I didn't. Yeah.
Oh, here they are. Then yeah,
Back well, archive is slightly different from a backup.
Totally. You know, you can.
Yes, that's absolutely that. And when you say Freezer, yes, you need to put that non-regenerate, that data that is unique and cannot be regenerated. You need to freeze it somewhere.
Yeah, that's it. But there are many other cases, I think, and it's not exhaustive. You know, if you have other ones, very happy to hear about it. So, thank you. Thank you.
Thank you. So now we're just going to head into the mini break. So if you can head back in here, if you want to see the next talk by 11:45, that would be great. And up next we have Karina from Amazon Web Services.